Hello guys, in this video I'm going to be taking you through this question. Evaluate the integral of ln 1 plus root x enclosed in brackets dx. So how do we integrate this? First of all, we are going to make t equals to 1 plus root x. And when we bring 1 to the other side, we have t minus 1 is equals to root x. And of course, we can square both sides, square of root x and square of t minus 1. Now, square of, we're going to have t minus 1 enclosed in bracket square is equals to root x squared. And of course, this will result into t minus 1 squared is equals to x. And from here, we can find the derivative of both sides. When we differentiate t minus 1 enclosed in brackets squared, we're going to have 2t minus 1 is equals to dx. So from here, we can come back here and then express the integral of ln 1 plus root x enclosed in bracket dx as integral of ln. Of course, 1 plus root x is t. So we are going to replace 1 plus root x here with t into dx is 2 into t minus 1. And of course, here 2 is a constant, so we can bring 2 outside. So we'll have 2 integral ln t multiplied by t minus 1. Of course, we can bring t minus 1 to the back of ln t. So we'll have 2 integral of ln t, t minus 1 ln t. And expanding or removing the brackets of t minus 1, we have to multiply each of the terms here, t term and the constant minus 1 by ln t. So we are going to have 2. We're going to have a bracket here. Okay. We're going to have 2 integral t ln t minus 2 integral ln t. The t here, the t here, the t, the t here. I'm going to have the t here. And of course, I can make I1 equals to the first integral, that's 2 integral t ln t dt. And then I2 equals to minus 2 integral of ln t dt. So I'm going to be integrating separately to make it much easier. So the first one is I1 is equals to 2 integral of t ln t dt. So we can integrate by parts. Integrate by parts, of course, using integration by parts. That is integral of u dv is equals to uv uv minus integral of v du. So we have to find each of these terms. We have to find v, we have to find for v, and we have to find for du. So we are going to make u equals to ln t. Ln t. So differentiating both sides, we'll have du is equals to dt divided by t. And for v, dv, for the v here equals to t dt. T dt. And when we integrate both sides, we'll have v is equals to, integrating t dt, you have t squared divided by 2. So we can now use this integral of u dv is equals to uv minus integral of v du. So we'll have integral of u here is ln t and dv is t dt. So we can still have it as t ln t dt is equals to uv, that's ln t and t squared divided by 2. So I'm going to have t squared, that's ln t, into t squared divided by 2 minus integral of v du. V here is t squared divided by 2. Du here is t dt divided by t. And of course, we can have it as, when you multiply ln t by t squared divided by 2, we'll have t squared divided by 2 ln t minus t here can go with the numerator, so you still be left with t. So you are going to have integral of t divided by 2 dt. And of course, this can be t times half dt, and half is a constant, so you can bring half outside. So we'll have t squared divided by 2 ln t minus half integral of t dt. And you can just integrate t dt. So you have t squared divided by 2 ln t minus half t squared, okay, in brackets, divided by 2 plus c. And when you multiply, you have t squared divided by 2 ln t minus t squared divided by 4 plus c. So we've been able to get I1. I1, that's the integral of t, that's 2 integral t ln t dt. So we've been able to get it as t squared divided by 2 ln t minus t squared divided by 4 plus c. And okay, and remember we have 2 here outside here as a constant, so we have to multiply each of these terms here by 2. We have to multiply each of these terms here by 2. Because of these 2 here, we have to multiply each of these terms here by 2. That's for t squared divided by 2 ln t and minus t squared divided by 4. So this is I1. Now multiplying by 2, we are going to have I1 is equals to, of course, 2 cancels the denominator. So you have t squared ln t minus t cancels 4, you'll be left with 2 here as the denominator. So you have minus t squared divided by 2 plus c. So we've been able to integrate 2 integral of t ln t. Now for the other, we have I2 equals to minus 2 integral of ln t dt. Of course, we've done it before. You can just watch my previous video to get the full explanation of the question similar to integral of ln t dt. So I'm just going to write it here. We have I2 is equals to integral of, that's minus 2 integral of ln t dt. Now when you integrate ln t dt, you have minus 2 integral in brackets t ln t minus t plus c. Now this will, when you multiply all through by minus 2, you have minus 2t ln t plus t plus t. Sorry, plus 2t plus c, which can be 2t minus 2t ln t plus c. So we've been able to integrate the both. We can now bring them together. Remember, we are trying to integrate. We are trying to integrate from here to integral of t ln t dt minus 2 integral of ln t dt. So we are just going to bring the both of them together. So we'll have this as our answer. Okay, let me write it first. Integral of, that's 2 t ln t ln t dt minus 2 integral of ln t dt. So this will give us, now for the first one, we got t squared ln t minus t squared minus 2 okay, t squared minus 2 and divided by 2, sorry. So t squared ln t minus t squared divided by 2. Now plus here, why? Because already we've integrated minus 2 here. We've integrated minus 2 already, so it will be plus what we have here, 2t minus 2t ln t plus c. And of course, when we come back here, remember we said our t is equals to 1 plus root x, which is what we're having here. 1 plus root x, so I'm just going to bring it back here. So I'm going to have 1 plus root x squared ln, okay, space will not be enough, so this will result into 1 plus root x squared ln 1 plus root x minus 1 plus root x squared divided by 2 plus 2, 1 plus root x minus 2, 1 plus root x ln 1 plus root x plus c. So this will give us the answer of the integral of ln 1 plus root x dx. So if you find this video interesting, you can as well like, subscribe, share, and comment what you feel and what you've learned in this video. Thank you.